Hi YouTube people, I am your teacher REGY SAFADÁO, and today we are going to study the definition of the analytic geometry, the Cartesian plane, and how to find the distance between 2 points. Are you ready? So, come with me! Hi YouTube people, I'm very glad to have you here back again in our channel. Today we are going to talk about the analytic geometry. Let's see our opening. As you already know, our channel is Mathematics Without Frontiers, and here we have classes of physics, mathematics, and English in 2 versions, one in English and the other one in Portuguese. Go there and visit our video classes in Portuguese. They are really terrific, okay? So let's begin. Well, let's see. When we talk about the analytic geometry, we have to talk about René Descartes. Well, he was a French philosopher and mathematician who developed analytic geometry, also said Cartesian geometry. Okay, well, let's see. Analytic geometry, definition, and Cartesian plane. René Descartes, well, he was born in 1596 and died in 1650, okay? Well, if you ask me what analytic geometry is, I can tell you, it is a branch of mathematics which uses algebraic equations and coordinate system to present and solve problems in geometry. Okay, so let's see what is a coordinate system or Cartesian plane. Let me show you. It is a system consisting of 2 perpendicular axes, okay? Okay, so this is the number line that from now on we are going to say it is x, and the other one is the y, okay? When they get together, that point right there, let me show you 1 second. Let me get a laser pointer to show you better. Okay, so this point right here, okay, is set the origin. Okay, so this is the number line x, and the x, and the other one is the number line y. Okay, the xy, and the 2 number lines must be 90 degrees. Okay, so a right angle between them. Okay, 90 degrees. Well, and so when you draw a Cartesian plane, you really find 4 different regions, okay? And these 4 different regions are also said quadrants, okay? They must be in the counterclockwise, okay? So this is the first region or the first quadrant. This is the second one, the third one, and the fourth one. But they must be set, they must be watched in the counterclockwise, all right? Let's show you. Okay, so this is the first region or first quadrant, the second region or second quadrant, the third one, and the fourth one. Okay, let's see now. Well, in fact, when René Descartes developed this part of the geometry, he wanted to plot points, okay, like this. Number line x, number line y. Okay, so point P is on the first quadrant, point R is on the second one, point S is on the third one, and point Q is on the fourth one. All right, let's plot them. Okay, some numbers, positive or negative. Okay, so pay attention right here. So P, x of P is 5, and the y of P is 3. Okay, so point P is 5 and 3. Okay, this is an ordered pair, okay, of numbers. So the first value always is x value, and the second one always is y value. Don't forget about it. Okay, let's see how to plot point R. Okay, you can see Here is -4, and here is 2, +2. So point R is -4 and 2. Okay, let's see point S. You can see here -3, okay, and -2. So point S is -3 and -2. Okay, plotting the numbers. Now let's see point Q. Okay, 3, +3, and -4. So point Q is 3 and -4. All right. Well, also we have to tell you in this study, we are going to study the points. To study the points. Okay. Let's see. We are going to show you how to find the distance between 2 points. Okay. There is a formula to get this. Okay. The formula is that the distance between point A and point B is the square root of x of B. Okay. Yes, x of B minus x of A squared plus y of B minus y of A squared. Let's see how to use it, how to apply it in some examples. Okay, we have 2 examples, and we are going to understand how to do it. Find the distance in centimeters between the points A and B. I'm gonna give you the Cartesian plane. Okay. Let's draw it. Okay, this is point A. Let's see point B also. And now I want to find the distance between A and B, points A and B. Okay, well, get a look at here. Okay, now let's see the coordinates of point A and the coordinates of point B. Let's see. Okay, A and B. Okay, so 1 is the x of A and 5 is the x of B. And 3 is the y of point A and 6 is the y of point B. Okay, let's get it down here. Here you can see A is 1 and 3 and B is 5 and 6. You can see very well. Now let's plug these values into that formula. Let's rewrite the formula right here. Just 1 second. Let me move my window from here. Okay, now let's plot. Let's plug them in. Let's plug the values of A and B, point A and B, into that formula. Let's see. So now we have the distance between A and B is the square root of 5 minus 1 squared plus 6 minus 3 squared 2. Okay, well, let's operate. 5 minus 1 is 4 and 6 minus 3 is 3. So now we have that the distance between A and B is the square root of 4 squared plus 3 squared. Well, 4 squared is 4 times 4 and 3 squared is 3 times 3. Okay, so we have that the distance is the square root of 16 plus 9. That is 25. So now let's get the square root of 25. That is 5. So the distance between points A and B is 5 centimeters. Okay, so example 1 is done. Let's go to example B. Okay, let's see. In the diagram below, point S represents a square and point B a bookstore. Considering, just 1 second, let me move again. Okay. Considering the kilometer as a unit of measurement, determine the smallest distance between the square and the bookstore. Okay, let's see the Cartesian plane once again. X, Y number lines. Okay, that is the square. S is the square and B is the bookstore. So don't forget one important point. The straight line is the smallest distance between 2 points. Okay. It's very important. Okay, so we want to find the distance between points S and B, or B and S. It doesn't matter if you go from B to S, or if you go from S to B. The distance is going to be the same. Okay. Well, let's see. So the coordinates of points S and B. Okay. All right, so 3 is the x of point S, and -2 is the x of point B. And -1 is the y of point B, and 2 is the y of point S. So let's plug the values. Okay, here we have that. S is 3 and 2, and B is -2 and -1. All right, so let's plug the values into the formula. Let me move my window just a little bit. Okay. It is okay. Okay, so let's see the distance. So the distance between S and B is -2 minus 3 squared plus -1 minus 2 squared 2. Okay, so let's calculate. Remember, -1 and -3 is -5. Very good. And -1 and -2. Okay, or -1 minus 2 is -3. Excellent. So we have now this -5 squared plus -3 squared. Well, -5 squared is 25, and -3 squared is 9. Very good. Now let's operate. 25 plus 9 is 34. Let's get the square root of 34. Okay, considering 2 places after the point, we have 5.83 kilometers. So this is the distance between the bookstore and the square. All right. Well, now our special thanks. Well, thank you very much, all of you that watch our videos until the end. Well, don't forget to subscribe to our channel, ring our bell, share this video with your friends, your classmates, your siblings, okay, all your neighborhood, and of course, give us your precious like. Okay, this is very important for us. Thank you very much. I am your teacher, REGY SAFADÃO. Okay, have all of you an excellent week. Bye-bye.
That's all, folks.